Good afternoon. I am Mohammed Naseera, working in Mallareddy Engineering College of Women's. I am in CSE department. Today we would like to discuss about CPU scheduling algorithms. Before going into that topic, let us discuss about certain keywords which make us easier to understand this topic. Firstly, let us know what is a process. What is a process? A program under execution is called as a process. A program when that particular executable file is loaded into the main memory, that program is undergoing certain changes. That changes are said to be a process states. There are 5 process states. The first one is new. In this particular state, the process is not yet created. This particular process, when it is created, first the operating system loads that particular program into the from the secondary memory into the main memory. Then that particular process is created. That thing is admitted into the ready state, which is the next state of the process. The first one is new state, the second one is ready state. In this particular state, that particular program, when it is created here, that is admitted into the main memory. From this particular ready state, when that particular program is called by the CPU for execution, then the process again changes its state, and that particular state is said to be a running state. Then from running state, this particular process, if at all it completes its execution, it is terminated, that is, it is killed. If at all this particular process requires any input-output operation, then this particular process goes to the waiting state, where certain events such as input-output operations required to complete the execution of that particular program is assigned to that particular process. Then again it is sent back to the ready state. Here a ready queue is maintained where the processes wait for its turn of execution. Now, here there are certain terminology behind learning this particular CPU scheduling algorithms. What are those? Firstly, we have to know what is the arrival time. Firstly, let us know about CPU scheduling algorithms. A process is, what is a CPU scheduling algorithm? A CPU scheduling is a process of determining. CPU scheduling is a process of determining which process will the CPU own for the execution. For that, the firstly as arrival time. Arrival time of a process is nothing but the time at which the process enters into the ready queue is called as a arrival time. The time at which the process enters into the ready queue is called as a arrival time. Then the time at which the process completes its execution is called as a completion time. The time at which the process completes its execution is called as a completion time. Then the time for which the process waits in the ready queue till it is called by the CPU is called as a waiting time. The time for which, the duration of time for which it waits for its turn for the CPU to call is called as a waiting time. The amount of time required by that particular process to complete its execution is called as a burst time. And the another one is the turnaround time, the total amount of time from when it has entered into the ready queue till it is terminated. That particular time is called as a turnaround time. These are certain terminologies we have to know before going into the CPU scheduling algorithms. Mainly the CPU scheduling algorithms. What is the main purpose of these CPU scheduling algorithms? To maximize the throughput, to minimize the waiting time, and to maximize the CPU utilization. Now, these scheduling algorithms are categorized into two: preemptive and non-preemptive. Preemptive scheduling algorithms and non-preemptive scheduling algorithms. What do you mean by preemptive scheduling algorithms? The preemptive scheduling algorithm is nothing but, in that particular case, the CPU is, what happens? It is assigned to that particular process for certain amount of time, or else it is that process is given, the processes are given certain priorities. Based on that, the CPU is utilized. But in non-preemption, what happens is the CPU does not leave the, the process holds the CPU till the termination, till its termination, till until unless the process executes completely, it doesn't leave that particular CPU. So, what is the preemption? A preemption is nothing but certain amount of time is assigned to the process by the CPU. In this particular preemption algorithm, we will be discussing about round robin scheduling, priority scheduling, SJF, and in non-preemption, FCFS is, first come first serve, SJF, shortest job first, highest response ratio next, multi-level queue, and priority. Now let us discuss these scheduling algorithms with an example. Firstly, we shall discuss FCFS, a non-preemptive mode of scheduling algorithm. FCFS is a non-preemptive mode of scheduling algorithm. FCFS is a non-preemptive mode of scheduling algorithm where the criteria is its arrival time. Where the criteria is its arrival time. Based on the arrival time, the name itself, first come, first serve. Based on the arrival time, we will be going to decide which process comes into the CPU and which process will wait in the ready queue. Let us discuss with the help of an example. In this, we have certain processes P1, P2, P3, P4 and P5 with their arrival times and burst times given. The arrival time and burst times of that particular processes are 2, 5, 1, 0, 4. And the burst times are 6, 3, 8, 3 and 4. Now, with the help of a Gantt chart, we will be deciding which process comes into this particular, which process is assigned to the CPU first. Okay. First, as I said earlier, based on the arrival time, this first come first serve algorithm, the main criteria is based on the arrival time. Based on the arrival time, the process P4 comes into the CPU first. Now, how much time it has? Because it is a non-preemptive algorithm, the CPU is utilized by the process till its completion. So, the 3 units of time it is being used by the CPU. Okay, the next process is P3. the P3 based on the arrival times we have taken. So 8 units of time. 3 plus 8, 11. So the next process comes into the ready queue is P1. So how much amount of time it is taking? Another 6 seconds for completing its execution. The next process that comes into the ready queue is P5. What is the time taken by the CPU? 4 units. That is 21. Next, P2. How much amount of time it has taken? 3 units of time. That is 24. So, based on this, depending upon this Gantt chart, now we have to calculate the turnaround time, waiting time, and the response time. How we are going to calculate this particular turnaround time? First, we know that turnaround time is equal to waiting time plus burst time, or turnaround time is equal to completion time minus arrival time. So first let us know the completion time. These are the completion times of this particular algorithm. Based on this, we have to calculate the average waiting time for the given processes. So okay.